Actually, the line has gone. The line was fluctuating. That's why it is interrupted. So in the instrument transfer that is almost completed. So the last point that we should consider that I have told you in the previous class that we should go through some instrument transformer, that how it can be managed or how it is shown. So in the last class we were discussing about this theoretical concept of instrument transfer. So, as we have already shown you the as I have already shown you the YouTube videos on the instrument transfer. So we will not going to discuss those things. So normally that your type of the transformer ratio that we have discussed also the transformer ratio that it is also had been discussed. Then there was then the characteristic of cities left. So the characteristic of the city is related with the effect of power factor of the secondary burden layer that depend upon the error of ratio error and the phase error. Then there was the effect of change of primary current, the effect of change of the secondary burden, then the effect of change of frequency. So these are some points of the characteristics of the city. Then there is a characteristics of the PT, that is the effect of the secondary current or volt ampere. That if when the characteristics of the PT is represented here, that if we increase the secondary burden, the secondary current is increased, and therefore the primary current increases. Both primary and secondary voltage drop increases, and thus for a given value of primary voltage, the value of the secondary voltage decreases, and hence the actual resistance increases as the burden. This is the explanatory part of the characteristics of the PT. So all of you must go through this and take the screenshot. Next point is the effect of PT on the secondary burden. So these are some explanatory part. As you can see, this is the city phasor diagram of the city. Here, as you can see, by looking the phasor diagram, you can easily convey that the phasor diagram is look like your simple two winding transformer. This is the load component of this is the load component, secondary component connected. This is the secondary current. When you draw the secondary drop voltage, this is the reactance that is at 90 degree from the resistance. So from there, you can see that this is the normal condition transformer city phasor diagram. This is the city burden at the leading power factor. As you can see, this is the leading power factor. That means with the IS value or the secondary value of the current will lead from this secondary voltage. So this is the secondary voltage, and this IS is leading from the secondary voltage by an angle of let us say delta. Okay. Now the phasor diagram of your PT potential transformer is this one. The phasor diagram of potential transformer look like this one. So power measurement of CT and PT, it has already been discussed in the previous classes. Now the working has already been completed. So this is the total effect, total part of your CT and PT. So this is the completion part of CT and PT. So all of you must go through the all of you must go through the your construction basic principle, different component of CT and PT, so that you can understand the basic things regarding your instrument transformer. Okay, so thank you very much for this. Okay, thank you. Actually, one thing is left, so we have to discuss those. Then this will be completed. So first, let me introduce this concept of the phasor diagram of the CT. So you can see here, this is the exciting current. This is the no load component of the no load current. This is the magnetizing current. Okay, or you can say core loss current is given as IC. The angle between this primary current and this I is taken as delta plus theta. This in IS is the phasor diagram for the normal condition of your city, and this is for your external burden when you provide it to the leading power factor. Then it is given as your city burden of the city of the transformer. Now there is a phasor diagram regarding your PT is given as phasor diagram of the PT is looks like this. Here also you can see that the IS is leading the VS. So it is a leading power factor. So this is the leading power factor concept. Here also you can say that IS excess, IS RS will be there because of the voltage drop, and this will be in parallel with the IS because of the both will be in parallel condition. Now this IS excess is the at 90 degree from this resistor. So from here the secondary output voltage is given by ES. Now from there you will see that from here this I exciting current is when you connect, this is the primary induced EMF in the primary side of the your potential transformer. Then there is this IP is your current in the primary current flowing. This is the load component. This is the load component referred in the primary side, or you can see second number of turns. The IS upon N is the load component. This is the primary current. So this primary current will be in parallel with this IPRP will be there because of the voltage drop that occurs in the primary side. Then there is a primary reactance drop that is related with your IP into XP. So this is at 90 degree from this IPRP to the accumulation part. This will give you the exciting current or the primary current that will flow. Now this IC is converted. This is your VP. Sorry, this is your primary voltage will be there. This IC is for your this one core loss current, and this core loss current, when you combine this core loss with the magnetizing current, you will get the no load current, that is I naught. That is your at there is an angle between the alpha. So accumulation of this part is very much easy because of the construction phasor diagram, which looks like your single two winding transformer. Single two winding transformer is related with this type of transformer phasor diagram of the PT, which looks like this. Now the power measurement using CT and PT is quite similar to that of this transformer. Here also that we have discussed in the previous classes, diagram had been shown where the CT, PT and the wattmeter was involved. Similar case of diagram is given here. Similar case of the diagram is provided here. Here also you can say the 1 ammeter is given, the current transformer winding or terminal is provided. Here H1, H2, then X1, X2. Then there is a voltage transformer is given where the voltmeter is provided. This is the grounding has been done. Here also the number, here also the dot convention is taken. That this is one for H1, this one for X1, this one current is in living from this H1 to H2, H1 to H2, and here also this dot will result the outward flow of the current that will X2 through X1, that will flow through the voltmeter, and this wattmeter how much energy has been consumed for this machine. So this is the total explanatory part of the CT and PT of the switchyard system. So here also you can see the transformer of the substation. Before that, this CT and PT is provided, and the load is given here. The load is given here. Now this is the power factor meter, which enhances the power factor of the system. As you can see, this is the three-phase system line. This is the reference point, and this is the okay. This is the power factor. You don't have to study. Okay. Now the power factor meter for electromagnetic type. This is the construction part we had discussed. This is the frequency meter. As you can see, this is used to measure the frequency of the machine. The circuit diagram is given here. This is called Wheaton frequency meter. As you can see, this is the RA, inductance LA, there is normal inductance L, there is a coil connected. This is the needle portion which represents the value of the frequency. This is for the higher value of the frequency, this is for lower value. This is the magnetic needle. The axis of the coil is this. This is the positive edge. This is the coil A. The main construction of the frequency meter is also explained here. That is, it consists of two coils mounted perpendicular to each other. The one is along the horizontal purpose, one is along the vertical position kept here. So it consists of two coils mounted perpendicular to each other. Mounted perpendicular to each other. Each coil is divided in two sections. Each coil is divided into, the figure shows the connection of the two mounted diagram. Then there is the branch circuit of the coil A has a resistor RA connected in series with this RA. This is supply value. This is the value of RB. This is the LB. This is the LA. This is the resistance RA. This is the inductance L. So all the components is clear where it is placed. The branch circuit of the coil A has a resistance RA connected in series with it. As this is the branch A, it is connected in series with RA. Then the moving element is a soft iron needle. This is the moving iron, that is soft iron needle. Then there is a coil B has a reactance coil LB in series. This LB in series with the coil LB. Okay, this is the coil B and this is the coil A. So those are connected in series. So these are some basic instrument. These are some basic instruments which should already studied in your instrument and transformer. So I'm not going to detail with this construction. So we only concentrate on the this working of the CT and PT. Working of the CT and so mainly a question arises: what is burden of the CT? What is the burden of the CT? So from the burden, you can see here the burden is given as it is convenient to express the load across the secondary terminal voltage. Secondary burden due to load. That means how much load is given to the secondary side of the your instrument transformer. You can see CT. This is taken as the burden. Burden is mainly given as the secondary current into impedance of load on secondary burden. So that is the condition. That is the condition of burden of the. That is the power of the. That is the main purpose of power of the burden of the concept of the burden of the transformer of the CT. Now, turns compression is named for the CT of the actual transformation ratio. Compensation means for CT the actual transformation ratio. Now, the correction by reduction in secondary winding turn is exact only for a particular value of the current and the burden impedance. CT in this case may be called as turns compensated. So these are some basic components that we had discussed in CT and PT. So this is all about this topic was left in the from the previous classes. So now the CT and PT component is completed. We will left with the only 3 experiments is to be conducted for the next session, next class. So this is all about today's class. Now I'm going to end this session. So thank you very much to all of you.